let's try again, right? So guys, just listen to me and I have to listen again. Okay. So what we're gonna do, is it just means that you have less time to work. So that's probably good. And I said it's gonna be chill. Anyway, so what we're gonna do here is to show how to prove a quadrilateral is, for example, a square. How do I prove? How do I know that? I know that this is a square, but how do I prove it? It's all in page 177. So let's start with a rectangle. There's two ways to prove that a rectangle is a rectangle. The one way is to show that first of all, it's a parallelogram, so I have to prove it's a parallelogram. And then to show that one angle is 90. If one angle is 90 and it's a parallelogram, therefore the opposite angle will be 90. Those two will also be 90 because they're cointerior, they add to 180, so all sides are 90. But you just need to show that one angle is 90. The second way of doing it is, forget about the angles, let's look at the diagonals. So if you show that both diagonals are equal and that they bisect each other, halve each other, then again that's a rectangle. Right, next thing. Now it's obviously very clear for you. You heard it for the third time. Okay, a rhombus. How do I prove that a rhombus is a rhombus? So I need to show first of all that I've got a parallelogram. If I show that a pair of sides, adjacent sides, are equal, that will be a parallelogram. That will be a rhombus. Why? If those two are equal, those two also must be equal because the opposite side in the parallelogram, those two are also equal. So all sides are equal, and therefore it's a parallelogram. The other way that you can show it's a parallelogram, you're looking at the diagonals, and you show that they are, first of all, bisecting each other. They don't have to be equal, like in a rectangle. They bisect each other. That means that is equal to that is equal to that. And the second bit, you need to show that they are perpendicular to each other. So if you've got a parallelogram where the diagonals bisect and 90 degrees to each other, voila, that's a rhombus. Square. There's three ways of proving that square is a square. First of all, if you know that you have a parallelogram and one angle is 90 degrees and two adjacent sides are equal, then that is definitely a square. Why is that? Because if this is 90, that will be 90, and that will be 90, and that will be 90, like we proved in the rectangle. But also that side will be equal to that side, because the opposite, and also to that, so we got a square. The other option is, let's say you have a rhombus. Okay? Let's say you know that this is a rhombus. All you need to show is that one angle is 90 degrees. Okay? Because if that's going to be 90 degrees, okay, that is also going to be 90 degrees. Okay? These two will be parallel, so that's also going to be 90 degrees. All sides are equal, all angles are 90 degrees. The other option is to show that I've got a rhombus with equal diagonals. So if you look at the rhombus, normally in the rhombus the diagonals are not equal. But if the diagonals are equal, then that rhombus in fact is a square. So a lot of stuff to remember. Trapezium and kite is easy. Okay, they are like different. We said they're not really the kind of outliers. So to show that trapezium is trapezium, all you need to show that you have two lines, two sides that are parallel to each other. The other two we don't care. And to show that a kite is a kite, basically we need to show that these two adjacent sides are equal and these two adjacent sides are equal. That's it. Okay? So it goes back to what I've been telling you again and again. You need to start thinking about writing down all the theorem, all this theory of geometry, writing down all together so you can come and look at it again and again before the test. Okay? Right, I'll pause here, I'll stop here.